Hey, what's up, guys? It's Hunter here, and today we're gonna start our first lesson on pre-algebra. Pre-algebra. You probably know what the first word or the first part of that word means. It means pre, which means before, and algebra. It's obviously a branch of mathematics. Pre-algebra. It's before algebra. Get you prepared for the It gets you prepared for the immense and vast and complex topics. But don't fret, because I think, in my opinion, if you can do the basic problems in the pre-algebra section, you can do pretty much anything. So, first thing we're gonna be looking at is just some basic stuff that you'll need to know before you can start pre-algebra. So I'm just gonna put basic stuff. Okay, so the first thing is that this thing over here, probably saw it before, it's letters, but it's also used in mathematics. You ever see this before? This here, the simple thing, it's letter, but it's also called a variable in math. It's a variable. It basically means a unknown value or a varying value. I know that's bad to use the word or the or the root word vary in its definition. That's pretty much what it is, though. It can be any value that's in an expression or that suits an equation. So so whenever you see 7y or just x or a or just like 3a, you need to know that this is a variable. Second part, say that you have something like this, 3x. Probably thinking this is 3 times and that this is incomplete because, what is it, 3 times 3? 3 times 4? No. When you just see a number and a variable next to each other, this basically means that it's getting multiplied together. Or this dot, we use this instead of the x because when you're multiplying, if you do this, it looks kind of weird. 3 times x. So we just use a dot instead. Sometimes we use this thing where in parentheses we either have the 3 or the x, and on the outside we have this. This means multiplication as well. Or you could have this. This all means multiplication, but the most conventional way, usually in pre-algebra and algebra, is just like this, variable next to the number. You could say, since multiplication is commutative, if you haven't learned that property, I suggest you do, can it be this? Even though that is still 3 times x or x times 3, we don't really use this way. We use this, 3 times x. So now that we got some of the basic stuff out of the way, let me just show you one more thing. If you say you ever have something like this, you have 2 over 4. Say, yeah, this is a fraction, but this also means division in mathematics. Like if in an equation you might see x over 4 equals 16 or something like that. This is the same thing as division, because if you think about it, you know that 2 divided by, or 2 fourths is equal to 0.5, and if you didn't know that, that's what it equals. But this is just the same thing as dividing 4 by 2. So it's 4 into 2. And if you do the long division, 4 goes into 2 0 times. 4 times 0 is 0. 2 minus 0 is 2. Now you have to get into decimals. If you don't know how to do that, you just should learn, because you are going to be using some decimals in this. But just the basic stuff of decimals. So how many times is 4 going to 20? 5 times. 0.5. That's basically what it is with every fraction. Say 3/8. This is equal to... Wait, let me get a, calculator. I'm gonna get a calculator real quick. She's like my assistant in this. But anyway, the point is that every fraction is basically a division. So, when you might come across an equation later on, you'll know it's division by the fraction bar. So let's just see, 3 divided by 8, or 3 is that's equal to 0.375. Or it's just the same thing as 3 divided by 8. But we don't really use 3 divided by 8 anymore. Well, as you get farther on to algebra and pre-algebra and stuff like that, we pretty much use this way. Fraction. Show division. So now that we've got some of this stuff out of the way, let's move on to 1-1. And I'm using the Glencoe pre-algebra book for this. I'm sorry if you guys are using a different one. You just have to bear with me for it. So we're going to be doing words and expressions. Words and expressions. Okay, so now that we saw what we're going to be doing, we are going to go over some problems and some keywords in this. The first one says the difference of a number, or the difference of 17 and 3. So the difference of 17 and 3. So the keyword there is difference. Whenever you see difference, you know that you're going to be subtracting. So that's the main operation for this. And we know that 17 and 3 are the main numbers in this. So when we see this, we know we're going to be subtracting. So this is equal to 17 minus 3. 17 minus 3, sorry. So, don't get confused this with 3 minus 17. That's if it was 3 and 17, not 17 and 3. So, and 17. That's the difference. My dad's over here. What's up, Dad? So, we're going to do another one of these. The second problem over here, shows this. It shows 11 more than 6. Whenever you see the key thing here, more than, you know that and I know this is not important, but the 11 is after the 6. But this is actually gets key when it comes towards like less, or yeah, pretty much less, or that's the only one that I can think of on the top of my head, but you'll see what I'm talking about later. So you know that this is equal to 16, and you see the more, you know that's plus. We're adding, addition. 16. 6 plus 11. So that's what 11 more than 6 is equal to. So just verify real quick. Keywords here are more and then 11 and 6. Okay, so let's go ahead and look at number 3. So it says here, the sum of 8, 20, and 5. So the keyword here is sum, and if you ever see sum, you know that you're going to be adding. You're adding here 8, 20, and 5. So we got 8, 20, and 5, and we're obviously adding, so I'm going to put the addition signs here. The thing is that you could write this in any way you wanted, but I would do it in order, because it just, when I do it in order just because when I see it verbally, I just translated it numerically in order. But this is also equal to, because addition is also commutative. This could be 8 plus 5 plus 20, or 20 plus 8 plus 5, etc. You probably know there's tons of combinations for that. But since it's commutative, you basically get the gist of it. And we'll review again. The add-ins are 8, 25, and keyword here is sum. That's how we know we're adding. So number 4 here says the quotient of 40 and 8. Sorry about the mix-up with me adding or putting it numerically and verbally. I think you understand. If you don't, I'm sorry about that. So, sorry. You see here that the main keyword we see in the beginning here is quotient. Whenever you see quotient, we know that we're using the division sign, also known as the fraction bar. But since we're just starting out, it can be either one. But I prefer if you guys stick with the fraction bar. Don't get this confused with this subtraction sign, the fraction bar. So we see 40 and 8. So we know that we're dividing. We have 40 and 8. You know that we're dividing these two numbers here. So we can either put this as 40 divided by 8 or 40 over 8. Both ways, you get the same answer, 5. But do not think because of this that division is commutative, because it's not. As you know, that's 40 divided by 8 is not It's not. And whenever you want to say something it's not equal to, you put the equal sign with a dash through it. It's not equal to 8 divided by 40. Because this down here is equal to 1/5. You can verify that for yourself. But just get the point across. It's not commutative. So just to verify, we have the quotient, which is the keyword showing for division. 40 and 8 are two numbers that we're using for the division. Yeah, okay, we're going to do around one more, and then we're going to do some evaluating with expressions. Okay, so we have 5 here. So we have 100 decreased. Sorry about that. Decreased by 25. Remember, do not get mixed up. Or first, let's just go over the keywords. The keyword here is decreased, and our add-ins are 100. Or sorry, our subtractees. I don't know how you'd say that. And 25. We know that we are subtraction. Do not think of this as 25 minus 100, because otherwise it would be 25 decreased by 100. So no. So we know that our new numerical phrase is 100 minus 25. Okay, so that's it for the I guess you could say verbal translations. Now we're going to do some actual evaluating. And the key word here is evaluate. Note that evaluates... Yeah, look up what evaluate means for me. Never mind, I'll just figure it out. Evaluate. That is to solve for a specified and clear, that's keyword, clear expression. And just to let you know, you'll only get one answer with this. Only one answer. That's the difference between the equations and expressions. That's the key thing to remember with when you evaluate expressions, you will get one answer. So let's do around a few of these. So we have 2 minus 3 times 0. Well, if you remember the order operations, I'll just write it here so you can remember. PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Remember that multiplication and division are left to right, so whatever one comes first. Same thing for addition and subtraction. So we can cross off here parentheses exponents because we don't have that, but we do have subtraction and multiplication in. So we know that multiplication becomes 4 addition, so we will do the 3 times 0 first. So 3 times 0 is obviously 0, so we're left with 2 minus 0. And we know now that we can do our subtraction, 2 minus 0 is equal to 2. So that's the answer for that one, which was number 9. Sorry, I should wrote that down. Okay, so now let's do number 10 here. And we have 25. I don't like the way that they have the division side, but I'm fine with it. Minus 4. 25 divided by 5 minus 4. So we here have division, and subtraction, and we know that division comes before subtraction, so we'll do that first. 25 divided by 5 is 5, and I hope you know that. And we bring down the minus 4, so left with 5 minus 4. I'm going to get some new paper here. We know that 5 minus 4 is equal to 1. And if you like, you can check your work, do the problem again, just to make sure that the answer is correct. I'm not going to do that, not because I'm better, because I know it's right, it's just want to save some time. So here we have 5 plus 2 minus 3. And I'll write the PEMDAS over here since I'm on a new page. I'll put because it's 2, it's left to right. Okay, so we have 5 plus 2 minus. We have addition and subtraction. We know that addition and subtraction, whenever you have that, it's left to right. So we do 5 plus 2, it's equal to 7. Now we're left with minus 3. So now we'll do the 7 minus 3. And we know that 7 minus 3 is equal to 4. So there's our answer. Okay, let's do one more here. Actually, no. We're going to do this one and then another one, like a more difficult one, I'd say. Yeah, okay. So, we have this one. 2 being multiplied by 4 plus 5 times 3. So, we have parentheses here and brackets, but we do what's inside the brackets first. And then, obviously, we have parentheses in here, so we do what's inside the parentheses first. So, we know that 4 plus 5 is 9, so we carry everything down. So, what's 9 times 3? You know that since we have multiplication, we can do the 9 times 3. And we know 9 times 3 is 27, so we're left with 2 times 9, or 2 times 27. So now we can do the multiplication. We know that 2 times 5 is 27, same thing as 20 times 2, which is 40, plus 7 times 2, which is 14. Left with 54. There's our answer. So we're going to do one more that I think is a difficult one. Oh yes, okay, 12. Okay, so we have 5 plus 2 times 8. Don't worry, that's not a subtraction. Plus 2 minus 5. So here we have multiplications, addition, and subtraction. So multiplication comes before addition and subtraction, so we'll do that first. 2 times 8 is 16, so we bring everything else down. Plus 2 minus 5. So now we just do it left to right, because addition and subtraction is pretty much whatever comes first. Now that 5 plus 16 is 21, plus 2 minus 5. 21 plus 2, that's 23, and with 23 minus 5. 23 minus 5 is equal to 18, so that's our final answer. Hope you guys enjoyed this video. Remember to like and subscribe if you liked the videos, pretty much. Bye. Oh, sorry.